In this video, we are going to see about the power quality disturbances that are defined by IEEE standards. So what is a power quality disturbance? We need a sinusoidal waveform for the equipment operation. So this is the expected output from a utility. But sometimes there will be a significant deviation in the waveform magnitude or frequency or the purity of the signal, which we call it as a potential power quality problem. So the waveform may be distorted. But how do you define which is good power or bad power? So it depends upon who you are. If you are a utility person, your tolerance level may be different and the consumer tolerance level will be different. So the power which you receive may be good or bad depending upon whether you are a utility person or a consumer. For example, you have an induction motor and you want to start this motor. So whenever you start a large induction motor, there is going to be a large inrush current. If you are a utility person, you will see that it's a current disturbance because when it will take a large inrush current, so your current is going to get disturbed. But if you are an end user and you are operating somewhere nearby this machine, certainly there will be a voltage dip. So when this machine started, you will experience some voltage dip. So at the consumer level, it can be a voltage disturbance. So if you are a utility person, it may be a current disturbance for you. But if you are a consumer, it may be a voltage disturbance. So it depends upon the situation as well as the person. So how do you decide whether the power quality is good or bad? If your equipment works perfectly, then it is of good quality. If it is not working perfectly or if it affects the normal operation of the equipment, it is making some noise or it is not working properly, we call it as the quality of the power is not good. So let us see some of the power quality terminology used. There are a lot of terminologies which may be confusing. So voltage sag, under voltage. Actually both specifies reduction in voltage. So when to use voltage sag, when to use under voltage. Similarly, voltage fluctuation term is there. Then voltage swell, over voltage, transient, interruption, outage, blackout, harmonics. So many factors are there or so many terms are used which is really confusing. So let us see what is the difference between these terms so that you can understand the power quality. There are various terminologies used to describe the power quality disturbances. It is always better to follow some standards. So this is the IEEE 1159 standard is used to define the power quality disturbances based on the wave shape. So we will see about that. First one is the transients. Next you have interruptions, sag or under voltage, swell or over voltage, waveform distortion, voltage fluctuations and frequency variations. So these are the 7 power quality disturbances defined by IEEE. So let us see about the first 4 in this video and the remaining 3 will be discussed in the next video. So let us see what is this transient first. What is the meaning of transient? Transient means something which lasts only for a short time. Okay. So it is not permanent, it exists only for a short time. So if you see this voltage waveform, you can see a spike here and it goes off immediately. So it starts here and it goes off immediately here. So it is a short-lived one. So this part we can call it as a transient. So transient or disturbances that occur only for a very short duration. Next, we will see about the types of transient. One is the impulsive transient. So you can see here an impulse will be there, and the thing you should note here is it is unidirectional. That is, if you take a sine wave, you have positive cycle as well as negative half cycle. So this one exists only in any one of the cycle. It can be either positive or negative, but it is always unidirectional. So the next type is called oscillatory. You know, oscillations means it keeps going like this. So this is oscillatory, it is bidirectional. Okay. So the best example for impulsive transient is lightning. So you know, impulse means at one strike you will get something. It can also occur due to switching on an inductive load or electrostatic discharge also. So let us see one waveform here. This is due to lightning. See here, it is in negative direction only. So it is unidirectional. A large spike will come and it will decrease after some time. So two things you can note here, the rise time and the decay time of this graph. So we can say that impulsive transients are normally characterized by the rise time as well as the decay time. And you should remember it is unidirectional in polarity. Next we will see about oscillatory transient. So the best example is back-to-back capacitor switching. It means that already a capacitor, you can see here existing capacitor is connected to a line and you are going to connect a new capacitor to it. So because of that you will get a waveform like this. So the current waveform, this is the current waveform, so it goes here and oscillates between two levels and it finally decreases. Okay, so this is an example of oscillatory transient. It can also be caused by capacitor bank energization and it is characterized by its frequency content and the duration as well as the magnitude. So if you summarize about transients, transients are disturbances that occur only for a short duration. There are two types, impulsive transient which is unidirectional in nature and oscillatory transient is bidirectional in nature. Now we will see about the next one, interruption. So what is interruption? You do some work and some phone call comes or somebody is interrupting your work. We call it as interruption. Same thing happens with the power. When there is a complete loss of voltage on one or more phases, we call it as an interruption. You can see this voltage waveform. The sinusoidal wave is here and for some time there is no signal or no voltage. Again, it recovers. So, when the supply voltage is either 0 or even it falls is less than 0.1 per unit, we call that as a interruption. But another factor is also important, duration. So this interruption should be only for a period less than 1 minute, that is 60 seconds. So the supply voltage should fall below 0.1 per unit and the time period should be less than 1 minute. So depending upon the duration, there are three different types of interruption. Momentary interruption, temporary or sustained, depending upon how long the interruption occurs. Next, we will see about voltage sag or under voltage. So, voltage sag and under voltage both represent the decrease in RMS voltage. But what is the difference between these two? You can see here in this voltage waveform, this is the nominal voltage and there is a reduction in voltage. So, do you call this as a voltage sag or under voltage? How do you differentiate them? So it depends upon the duration for which this decrease occurs. So if the reduction in voltage is less than 1 minute, we call it as a voltage sag, and if the reduction in voltage is more than 1 minute, we call it as a under voltage. So what is the necessity to differentiate this voltage sag and under voltage means in some cases, that is in some applications, voltage sag, the equipment can withstand the voltage sag. Okay, so in such cases, there is no need to trip the relay. So you might have seen under voltage relays. So only when the voltage sag is more than, the reduction in voltage is more than 1 minute, you can make the relay to operate, or unnecessary tripping will occur. If every time it senses a small voltage sag, if the relay trips, it will be a nuisance. So to avoid that, they have differentiated the voltage sag and under voltage. So next we will see about the swell or over voltage. Again, both represents the increase in RMS voltage, but the difference lies in the duration of the increase in voltage. So this is the nominal voltage, and here you can see there is a voltage swell. Now we can classify whatever we have seen into short duration variation and long duration variation. Okay, just to summarize so that you can remember it easily. So this sag, swell or interruption always exists less than 1 minute. So all these things comes under short duration variation. So what are the causes for this sag, swell or interruption? Mainly falls, or if you energize a large load, there will be a high starting current. So a sag may occur. Then any loose connection. Because of all these things, this short duration variations can occur. And if you take the long duration variation, mostly they are under voltage and over voltage only. So this under voltage can be caused by load variations, switching on an inductor, overloaded circuit, loose connections. And if you take over voltage, it can be caused by switching off a large load, switching on a capacitor. So let us recall what we have seen. Any significant deviation in the waveform, we will see it as a potential power quality problem. The power quality disturbances defined by IEEE are transients, interruptions, voltage sag, under voltage, swell or over voltage, waveform distortion, voltage fluctuations and frequency variations. Out of these, the first 4 we have seen in this video, and the next 3 will be discussed in the next video, that is part 2 video. If you like the material, do subscribe to Read Electric Vehicle channel. Thank you.